More than 8 billion tons of plastic waste are turning our oceans into a giant dumping ground, where the waves no longer carry the taste of salt, but the traces of humanity's indifference. Faced with this reality, many countries have given up, but not the United States. In America, brilliant engineers refuse to stand by and watch the ocean slowly die. They designed an intelligent collection system that allows marine debris to drift into a capture zone on its own, using the power of natural ocean currents. But what makes this massive machine run so smoothly in the open sea, where nothing is predictable? Let's join Mandarin Tech and uncover the secrets behind it. Each year, more than 20 million tons of debris flow into the ocean, and nearly 80% of it is plastic, a material so resilient that it can endure underwater for centuries. These fragments accumulate into enormous floating garbage zones and quietly seep into the marine food web, harming more than 700 ocean species and eventually impacting humans. According to environmental organizations, if this waste were properly retrieved and reprocessed, a large portion could be transformed into valuable resources, from repurposed plastics and engineered fibers for the textile sector to reclaimed metals. This recovery process saves thousands of kilowatt-hours of energy, prevents millions of tons of CO2 emissions, and helps shape a circular ocean economy where discarded materials are given a new life and purpose. The process of reclaiming waste from the ocean starts with retrieval, and gathering such vast volumes of debris in the unforgiving conditions of open waters requires nations to deploy highly specialized technological systems. In major accumulation areas, such as the North Pacific Gyre or the Gulf of Thailand, dedicated cleanup vessels serve as the primary workhorses. Each vessel operates with two hydraulic mechanical arms that extend outward, sweeping across the water in a broad, fan-like pattern to capture drifting refuse, from plastic bottles and discarded bags to derelict fishing nets. The collected material is directed into floating channel systems linked to the ship, then moved on to stainless steel conveyors positioned on the deck. There, the debris is funneled into large holding compartments. A single cleanup operation can run for 8 to 10 hours, gathering as much as 5 to 10 tons of mixed marine waste. Not all discarded material makes its way into the open sea. A large share becomes lodged in rivers, reservoirs, and canals, where it builds up into dense layers that restrict water movement. In these environments, compact mechanical equipment is deployed, most commonly clamshell excavators mounted on dump trucks. Each steel bucket, weighing close to 1,000 pounds, can reach deep below the surface to scoop up mixed debris, bottles, plastic bags, branches, and even old tires. Every single lift can remove between 500 and 1,000 pounds of trash, and with the help of hydraulic power, one crew can clear a river segment hundreds of feet long within just a few hours, nearly 10 times faster than manual cleanup. Yet in many coastal regions, collection still depends on local fishermen and volunteers who use small nets and hooks from their boats under the scorching sun. Each individual may retrieve only a few hundred pounds of waste per day, but their effort represents the essential first step in the ocean's recycling chain. After the retrieval stage is finished, the collected waste is carried back to shore by trash skimmer vessels, specialized boats engineered solely for capturing floating debris. A compact skimmer measuring roughly 25 to 30 feet in length can accumulate around 5 tons of material during an 8-hour operation. When its storage area reaches capacity, a hydraulic conveyor at the bow lifts and discharges the entire load into the receiving zone on land. At this point, the preliminary sorting phase officially starts. The freshly offloaded mixture includes a wide spectrum of items: plastics, metals, wood, seaweed, and organic sludge. Workers conduct a rapid inspection to remove oversized or dangerous objects, such as steel nets, oil buoys, and tires. The remaining material is then shoveled onto a feed conveyor that transports it into the screening system. Inside the sorting line, a trommel drum classifies the waste by particle size. Sand, silt, shells, and tiny fragments pass through the perforations, while bottles and packaging stay inside. This residual stream which consists mainly of plastics and nylon, moves to a manual sorting belt where workers separate each category in preparation for the next stage of recycling. Once the detailed sorting is completed, materials like metal, glass, and wood are routed to their dedicated processing lines. Plastic, however, the planet's most enduring yet problematic substance, is set aside to begin its path toward renewal. Join the Factor as we uncover how humanity converts drifting marine debris into reusable resources that power a more sustainable future. After the recyclable fraction of the waste, mainly plastics, nylon, and metal cans, is separated, it is moved to the washing stage. This step is essential before any recycling can take place, since ocean debris typically spends long periods submerged in saltwater and becomes covered with algae, oils, and microbial growth. Inside the processing zone, the material is fed into a mechanical wash tank, where rotating shafts equipped with paddles generate a turbulent flow that scrapes off surface buildup and rinses away impurities. The wash liquid is formulated with gentle cleaning agents and a chloride neutralizing compound to eliminate salt and oil residues. In some facilities, hot water ranging from 160 to 180 degrees Fahrenheit is used to boost the effectiveness of sterilization. The cleaning phase typically lasts from 15 to 30 minutes, depending on how heavily the waste is polluted. Once cleaned, the materials move into a drum washer, which spins while blasting them with high-pressure water streams to dislodge stubborn sand and algae. Afterward, a float sink tank classifies the plastics by density. PET settles at the bottom, while HDPE and PP remain afloat, ensuring proper separation before the recycling stage. The freshly washed material is then transferred to a centrifugal dryer to extract remaining moisture, followed by hot air drying at roughly 170 degrees Fahrenheit. In larger plants, ozone-based deodorizing systems are added to treat vapor emissions, removing organic smells and neutralizing bacteria. Once the collected plastic waste arrives at the facility, the first step in the recycling workflow is pre-sorting, dividing plastics by category and size to prepare them for more advanced processing. Although 7 major plastic types are used globally, PET and HDPE are the 2 most efficiently recyclable, so the system prioritizes separating these from the rest while excluding incompatible materials. The mixed plastic feed then moves into a large rotating steel drum. As it turns, small perforations let dust, sand, and fine particles drop out, while larger bottles continue moving forward. This stage provides a coarse size classification that helps prevent blockages in subsequent equipment. Next, the stream travels along a manual sorting line, where workers pull out unwanted items such as metal cans, nylon, and cardboard. Simultaneously, an automated cap and label remover uses vortex air pressure to strip away different plastic components. Magnetic detectors continuously scan the flow, ejecting any residual metal pieces or staples. After this mechanical purification step, the remaining material consists primarily of clean, uniform PET bottles, now ready for the grinding phase that follows. The bodies of the plastic bottles are then directed into a high-speed granulator. Inside the chamber, hundreds of alloy blades spin at several thousand revolutions per minute, slicing the bottles into small pieces known as flakes. In a single hour, one machine can handle between 2,000 and 3,000 pounds of plastic, transforming what was once a mountain of bottles into a steady flow of uniform material within minutes. The resulting flakes, only a few inches in size, are small enough to move through the next thermal processing systems without causing blockages. This grinding step not only reduces the material's bulk, but also enhances energy efficiency in later stages. Once the plastic is broken down into fragments, it melts more quickly inside the extrusion unit, cutting electricity use by up to 40% compared with melting solid plastic chunks. The granulation phase also acts as the first level of size control, ensuring the feedstock is consistent before it proceeds to the next stage of precision sorting. At the microscopic scale, optical systems take control, with high-speed sensors examining each individual flake and assessing its color, clarity, and surface characteristics in just a few thousandths of a second. When the equipment detects a transparent PET fragment, a green PET piece, a white HDPE particle, or an unrelated material such as wood or glass, a precisely aimed jet of compressed air removes it from the mainstream. A single unit is capable of handling more than 1,000 particles every second, maintaining an accuracy level exceeding 95%. Each air pulse is directed at only one tiny fragment, weighing less than 1,000th of an ounce, without disrupting the nearby material. The outcome is a flow of clean, uniform plastic flakes sorted neatly into distinct categories, forming the essential base for the pelletizing stage that comes next. The approved plastic flakes are delivered into a large-scale extrusion unit where they are heated to roughly 520 degrees Fahrenheit. At this temperature, the plastic liquefies and moves forward along a massive rotating screw. As the pressure builds, the molten material is forced through an ultrafine metal screen that captures any lingering contaminants. The refined plastic melt is then directed into an underwater pelletizing system, where it is instantly chopped into millions of tiny granules known as pellets. A closed-loop cooling circuit solidifies the pellets immediately upon cutting, giving them a consistent size and smooth finish. These pellets become industrial-grade feedstock, ready for use in producing packaging, synthetic fibers, or even molded into brand-new bottles, completing the transformation from discarded waste to valuable resource. From these recycled PET pellets, the factory moves into the preform molding phase, the step where a partially finished shape is created before it becomes a full bottle. The material is checked for consistency and then sent into an injection molding unit, where it is heated to roughly 480 degrees Fahrenheit. In this softened state, the plastic is injected into a steel mold, forming a thick-walled tube with a threaded opening already designed to fit a bottle cap. Each preform is engineered to endure both elevated temperatures and internal pressure, ensuring stability during handling and during the subsequent reheating stage required for blow molding. Its compact geometry makes storage and transportation highly efficient. Many manufacturers focus exclusively on producing these preforms and then deliver them to bottling plants located near consumer regions, where they are reheated and expanded into their final bottle shape. In the following phase, the preforms are heated until they reach a pliable, rubber-like condition, then transferred into a stretch blow molding machine. High-pressure compressed air is injected through the neck, causing the softened plastic to expand and press firmly against the interior surface of a metal mold shaped like the final bottle. A preform only 4 to 5 inches tall can stretch to nearly 4 or 5 times its original dimensions. Once the blow molding step is completed, each automated line is capable of producing thousands of bottles in mere seconds with an almost zero defect rate. Laser-based inspection systems constantly monitor wall thickness, symmetry, and transparency to maintain consistent quality. Beyond typical bottle designs, the machinery can adjust volume, contour details, and label positioning to match each brand's specifications. After this stage, a fully shaped PET bottle emerges, ready for cooling, capping, and packaging. After leaving the mold, the bottle body is still extremely hot and prone to distortion, so the production line immediately guides it into a rapid cooling chamber that uses either chilled air or circulating water. This stage lasts only a few seconds, yet it is sufficient to stabilize the structure and lock the shape in place. In some advanced facilities, the heat released from the freshly formed bottles is captured and reused to warm the cooling water, greatly lowering overall energy usage. Once the plastic has completely solidified, the bottle attains the necessary mechanical strength to endure internal pressure during filling and transport. The cooling rate is carefully engineered to optimize output speed while preserving the bottle's ideal clarity and rigidity. Before leaving the production facility, every plastic bottle must pass through rigorous quality checks. Optical sensors, high-resolution cameras, and pressure testing systems identify even the tiniest flaws, including micro cracks, trapped air bubbles, or dimensional inconsistencies. Certain samples are selected for mechanical evaluations such as tensile strength, compression, and impact resistance to confirm overall durability. For bottles designated for food applications, additional chemical screening ensures that no harmful residues are present. Only after satisfying all requirements are the bottles grouped together, stacked onto pallets, and shrink wrapped for protection. Automated palletizing robots arrange thousands of units with inch-level accuracy, tagging each batch with a unique traceability identifier. From the central distribution area, the finished goods are shipped to beverage factories, supermarkets, or retail locations, completing the transformation cycle of recycled plastic. Each newly produced bottle is more than a consumer product. It represents the outcome of a circular technological system where discarded material is reborn as a valuable resource. So, you've just explored the full journey of how we collect, clean, and transform ocean-bound plastic into a completely new material cycle, from waste drifting across the sea to renewed resources powering modern manufacturing. The process is far more extraordinary than it appears. All the information in this video is compiled from multiple reputable sources, so if you notice anything that needs clarification or correction, feel free to leave a comment and let me know. If you believe that recycling can shape a better future, leave a like, share your thoughts below, and subscribe to Mandarin Tech to discover more stories of renewal, innovation, and transformation.